Okay, hello everyone. We are the Stroke Squad, and our goal is to identify cerebral infarctions in post-ischemic stroke patients. My name is Ansley Grashof.
I'm Chris Payas.
And I'm Ashley Naidel.
And we will go ahead and get into it.
So a general overview of the problem. Ischemic strokes result from the obstruction of blood supply to the brain and account for the vast majority of strokes. Prolonged inhibition of blood flow to the affected area can result in localized tissue death, which is known as an infarction. Up to 50% of adults are affected by silent cerebral infarctions, asymptomatic strokes, the effects of which are recognized through magnetic resonance imaging. The aims of this study include the MRI and its subclasses are crucial ways of both diagnosing acute ischemic strokes and determining treatment. We will focus on diffusion-weighted imaging, which are typically used to recognize disease onset early on. The goal of our study is to conduct a threshold image analysis using MATLAB to compare DWI MRI images of both healthy and post-ischemic stroke patients to aid in the identification of cerebral infarctions.
So these are just an example of what the DWI MRI images look like of cerebral infarctions.
And now we move on to a MATLAB demo. So here is this. I'm just going to go ahead and start it. So normal images should be in a folder titled normal images. This is because I have the add path code here, and that's just to help maintain uniformity and make it easier to use. Also, we used PNG images, but others can be used. So step one, we're uploading normal images, and this is to develop our baseline for the thresholding. And I'm just going to say we do want to see the normal images so we can see that that's here. So infarctions, as we saw on the previous slide, show up as lighter in color on a scan. So we're choosing a threshold value of 170, and now we're going to establish that baseline by thresholding all of these images. So I'm going to select them all individually. And this is all part of the graphic user interface, or GUI. And this is just to help make sure that it's intuitive and that anyone can use our code. So this is image 1, image 2, and image 3. And then we also have a weight bar to show that each image is being thresholded. So that's here. Now step 3, the determined upper limit of the thresholding is 1715. We just rounded it up to 1800. And as we go on, we have step 4, which is selecting the test image. So we're just going to go ahead and do, for example, image 1. And we'll just say we do want to see the image so we can visually inspect it. So as we can see here, there is a cerebral infarction present. So well, it's going to threshold, and this is just to show that it's not frozen. And then we have, let's see, step 6. So the code is down here. It should show us whether it's healthy or cerebral infarction present. We are expecting it to say cerebral infarction present. And there we go. So now then we're going to show one last slide, and I believe that, yeah.
Okay, so it's easy to see the output, and the user must only enter one image to get a result. So this is a very intuitive interface, as Chris was saying. Viewing the binary image allows the user to see roughly where the cerebral infarction is, except however, cons are the image must fit into a certain size range, and the images must be in very high contrast. So we thank you for your attention, and hope you enjoyed our overview of the code. Thank you.